Well, hello there. It's the next day. I lied. If you listened to this presentation closely yesterday, I said we'd move on to trapezoids. Surprise, surprise, we are still in parallelograms, but we're in the special types of parallelograms. We're going to be looking at the family of parallelograms that includes your friend the rhombus, your friend the square, and your friend the rectangle. All right, so within the quadrilateral family, we've got the parallelograms, and then within the parallelograms, we have those three shapes, the rhombus, the square, and the rectangle. Of course, slightly better representation here lets you know that if you are a rhombus, you've got four congruent sides, so each side has the same length. If you are a rectangle, you've got four right angles, so each angle in a rectangle is exactly 90 degrees. And if you have the characteristics of both, if you are a rhombus and if you are a rectangle, then you are a square. So the square is kind of like the coolest of the parallelograms as far as high up on the echelon goes. So for the rhombus, the rectangle, and the square, rhombus happens to be a parallelogram with four congruent sides. Rectangle is a parallelogram with four right angles, and of course the square is a parallelogram, and it's got four congruent sides and four right angles. That means that the square is also a parallelogram, the square is also a rhombus, the square is also a rectangle. You can get in almost any club it wants. They rode the wrong bus. Okay, maybe it wasn't that funny. I prefer rhombi instead of rhombuses, but because I do a lot of copy and paste off of different sources, you'll usually see rhombuses because that's how math books seem to like to do the plural form. Now, notice that you don't have to first prove that it's a parallelogram. If you already know it's got four sides, you know it's a quadrilateral. If you can show all four sides are congruent, well, gee, it's a rhombus. You don't have to show it's a parallelogram first. You can go straight to the fact, hey, four congruent sides is a rhombus. And of course, it's also a parallelogram if it's a rhombus. Same thing with rectangle. You don't first have to prove it's a parallelogram. If you've got four right angles, you know it's a rectangle. And then with the square, again, you don't have to first prove it's a parallelogram. If you can show that it's got four right angles, if you can show it's got four congruent sides, it has to be a square. So there's your formal definitions. Special thing about a rhombus, the diagonals are perpendicular, right? This is not true of a rectangle. It's not true of any old parallelogram. You have to be a rhombus. If you are a rhombus, the diagonals are perpendicular. Now, of course, since a square is a rhombus, it also applies to a square. But the key thing is, if you are a rhombus, four congruent sides, your diagonals are perpendicular. Also with the rhombus, the diagonals bisect each pair of opposite angles. So if you see in that middle diagram, angle A is being bisected by segment AC. Angle B is being bisected by segment BD. And of course, the rectangle diagonals theorem, instead of being perpendicular to each other, they bisect each other. Now notice the rhombus did not bisect each other with their diagonals. The rectangle does, though. Of course, since the square is also a rectangle, anything that applies to the rhombus or the rectangle also applies to the square. So for the square, not only would the diagonals be perpendicular, they'd also be bisecting each other. Okay, what would be the easiest angle to figure out first? Well, Angle 1 might be the easiest. You know it's got to be 90 degrees because you know the diagonals have to be perpendicular. Just by eyeballing, you can probably figure out that angles 2 and angle 3 have to be the same as that 61 degrees. But if you want some official reasons, you'd actually probably go to angle 2 first. And your official reason for angle 2 is that you've got alternate interior angles, right? Because side AB is parallel to side DC. AC would be your transversal. And of course, the official reason for angle 3 also having to be 61 degrees is that that angle has been bisected. So if I referred it to as angle A, that's not quite accurate because there's more than one angle there. If you think of the original rhombus, it would be angle A. Or now that the diagonals are there, it's angle DAB. But angle DAB has been bisected because it's a rhombus. Right? Either I have to be told it's a rhombus in the directions, or I need to see the marks so I know all four sides are congruent. And then for angle 4, again, you can probably eyeball it and figure out what it has to be, but if you want to know officially why it has to be that case, well, triangles add up to 180 degrees. Angles 1, 3, and 4 are inside a triangle. You already know the measurement of angle 1. You already know the measurement of angle 3. The only one you don't know is angle 4, but you know they got to add up to 180. You can quickly deduce that the measure of angle 4 has to be 29 degrees. So you can start working on a worksheet. And then when you complete the worksheet, you can move on to an IXL. If you complete both the worksheet and the IXL, you'll be done for the day.